Hello and welcome to another deep dive episode on the Total Space Network. I'm Ryan and joining me is...
I'm Mikko, and today we are talking about OSIRIS-REx and other asteroid missions.
Okay, so we'll start off with OSIRIS-REx, the most important one in recent days. OSIRIS-REx, the actual name, is Origin Spectral Interpretation Resource Identification Security Regolith Explorer. Christ, that's a long mouthful, that one. Thank God they called it OSIRIS-REx. It's a NASA asteroid study and sample return mission. The mission's primary goal is to obtain a sample test of at least 60 grams of regolith from Bennu, a near-Earth asteroid, and return it back to Earth for detailed analysis. The material return is expected to enable scientists to learn more about the formation and evolution of the solar system and the source of organic compounds that led to formation of early life on Earth. This one, go back at the history of this mission. It was actually launched on Atlas V all the way back on the 8th of September in 2016. Since its sample collection just in the past week, it's not actually going to return to Earth until around 2023. Bennu itself is around about 510 metres in size, wide or height if you like. A reasonably sized asteroid, that one. Successfully tagged Bennu on the 20th of October, a little bit harder than expected.
Yeah, I think it went inside the asteroid about half a meter or so.
Yeah, as I said there, it was planned to collect 60 grams of material, but one of the guys have come back and said he actually collected up to 400 grams, which a little bit more.
Yeah, that's great. Unfortunately, there was a little problem.
Yeah, the samples are leaking out the lander now. Lander or satellite, however you want to call it, because it it actually worked too well. It quite possibly picked up too much, and rocks, boulders, or whatever you want to call it, have just clogged up the actual door of the little collection sample. So they're trying to figure out how to disperse some of the sample and get the little hatch closed so it can actually have a safe return.
Yeah, I think I actually saw a tweet that they are already a couple of weeks ahead of time and are closing the hatch quite soon, within a week, I think.
Yeah, so if needs be, if they had to shed some of that sample material, I don't think it'd be too much of an issue, I imagine. I think they said they've already lost 5 to 10 grams of it due to the little minor problems they've had of trying to close that hatch.
Yeah, that sounds like it's going to have enough material to do some studies on Earth.
Yeah, and this one was actually developed by Lockheed Martin, who I've involved with a lot of projects lately, and they're actually one of the guys that are part of the double team that formed ULA alongside Boeing.
Yeah, and probably the mission launched on a ULA rocket.
Yeah, it launched on the atmosphere, as I said earlier on. Absolutely unbelievable rocket. The Dominator, as Tori always calls it.
Yeah, Tori is a fun guy.
But like we mentioned in some previous episodes, talking about Mars, talking about the moon and everything like that, hopefully gets some really good promising samples from Bennu in materials that's essentially the seeds of life from asteroids that came to make Earth.
Yeah, it could give us a real view on how the solar system looked millions or actually billions of years ago.
Yeah, sure. And there's been various other satellites and missions regarding deflections and stuff like that and samples. One of the main ones coming up in the next year or so for asteroid redirection is the DART project.
Yeah, that's an interesting one. So DART, Double Asteroid Redirection Test, it's a mission planned that will demonstrate the kinetic effects of crashing an impactor spacecraft into an asteroid moon for planetary defense purposes. The mission is intended to test whether a spacecraft impact could successfully deflect an asteroid on a collision course with Earth. Sounds like a pretty small satellite to actually alter course of an asteroid.
Yeah, because the satellite weight of it's only 500 kilograms from what I've seen, and this asteroid that they're intending to hit is in the region of 150 to 160 meters wide, something like that. So it'd be kind of like driving your little, well, what you call a Mini Cooper, if you're familiar with like a little small two-door car, if you like. Essentially driving that into a massive asteroid that weighs tons, hundreds, thousands of tons, God knows how much. It's incredible.
Yeah, the difference is that it's gonna have quite a lot of speed, going 6 kilometers per second.
Yeah, and when they hit the asteroid, they're trying to just make ever so slight small change in trajectory of the asteroid. So over time, over months, years, it'll lead to a large shift in the path. And that asteroid that it's planned to hit is Dimorphos, I think it's called. Correct me if I'm wrong.
Yeah, sounds good to me. Was its earlier name Didymos B?
Yeah, there's two. There's the larger one, which is, I forget how big it is, but the main target at the moment is the B one, which is only 160 meters in size. Because I believe the other one's around about 780 meters, which is a bit more of a giant compared to that little one. So I think by the looks of it, they're going to go for the easy target at the moment.
Yeah, they would probably need quite a bit bigger spacecraft to alter that asteroid's course.
Yeah, and also on that DART project, there's actually two small CubeSats from the Italian Space Agency that will piggyback on the DART mission, and they will separate shortly before the impact to acquire images and other ejecta that drifts past the asteroid. So there's a slight chance that we might actually see, whether they disclose it or not, actually see that impact on the asteroid.
Yeah, that's possible. I don't think we'll get the live view, but I hope we get at least a few images taking of the impact.
Yeah, it's one of those promising projects, the DART mission, because we've all watched one of the movies, Deep Impact, and all the other end-of-the-world movies there. Asteroid heading towards Earth, what we're going to do, blow it up, deflect it, do this, do that. It's kind of one of those projects. It's quite exciting, really, just to see is it actually possible to move this gigantic lump of rock just slightly, just so we can deflect it and move it on a different path.
Yeah, that's really interesting to see, and many of the movies are quite wrong trying to nuke the asteroids, because if you explode the whole asteroid, it's just going to be another...
It just creates like loads of separate smaller asteroids that could potentially create a bigger problem. It could just split the asteroid in two and create a double whammy effect. So rather than it just hitting the Pacific Ocean, it could end up hitting Central America and Central Europe as it splits in two or something like that. So it just creates a end of the entire world situation, not just part of it.
Yeah, that's one possibility. But I actually read a paper that discussed that the asteroid could actually come together again due to gravity. So the asteroid would eventually be almost the same, but with radiation.
Yeah, because it only has to be within a certain area and it'll just bring itself back together within reason.
Yeah. The mission is supposed to be launched on a Falcon 9 rocket in July 2021, and it should impact the asteroid in October 2022.
So a relatively short journey to the asteroid there, isn't it? I think the fuel for that one, it's actually using like a solar-powered ion thruster of some sort, which is quite interesting to gain that high velocity speed.
Yeah, some kind of next ion thrusters that are a type of solar electric propulsion, and it will be powered by 22 square meter solar arrays to generate the needed power. The name of the engine is NASA Evolution Xenon Thruster Commercial Engine, NEXT-C.
Yeah, because those ion thrusters are pretty much used on most satellites and everything, and some deep space satellites as well. To what extent their capability is, we're still not quite sure, because they're testing a lot of the newer versions of the ion thrusters on the mysterious X-37B from Boeing.
Yeah, they also use those not maybe the same, but similar ion thrusters on OSIRIS-REx spacecraft. So that made the mission possible.
Yeah, definitely. And another asteroid hunting one, if you like, Lucy.
Lucy is one of the few asteroid missions to come within few years. Lucy is the first mission to the Trojan asteroids, and they are time capsules from the birth of our solar system more than 4 billion years ago. The swarms of Trojan asteroids associated with Jupiter are thought to be remnants of the primordial material that formed from the outer planets. Trojans are located around the two Lagrange points, equidistant from the Sun and Jupiter. At the Lagrange points, the gravitational forces of the two large bodies cancel out in such a way that the small object placed in orbit there is in equilibrium relative to the center of mass of the large bodies.
And correct me if I'm wrong here, but that area is where a lot of the asteroids, within reason, orbiting in that area, isn't it?
Yeah. In this mission, there's also a main belt asteroid that Lucy will visit.
Yeah.
Most of these Trojan asteroids, they are going to stay in orbit of Jupiter. I would think some of those may become dangerous to Earth as well.
Yeah. And again, these are vital clues to decipher in the history of the solar system. Like we've seen with Bennu. I mean, even similar to the moon, they might have similar materials on there, because essentially they're all made up from the early materials of the universe and our solar system, but perhaps even the origins of organic material on Earth and everything. The mission takes its name from the fossilized human ancestor named Lucy, whose skeleton provided unique insight into humanity's evolution. Likewise, the Lucy mission will revolutionize our knowledge of planetary origins and the formation of the solar system.
Yeah, it's nice to see them name the missions after some of our forefathers.
You quite often see that with a lot of missions, don't you? Which is just kind of nod to history and inventors and scientists alike.
Yeah. So Lucy will launch in October 2021 aboard an Atlas V401 rocket, and its journey to 8 different asteroids will take a total of 12 years. And one of these is a main belt asteroid, and other 7 are Trojan asteroids. And the first encounter is scheduled for 2025 and the latest for 2033. So by that time, I think we would hopefully be on Mars, or at least some humans.
And a few more wrinkles.
Yeah.
But the interesting thing about this launch is that SpaceX filed a protest with the Government Accountability Office over that award. They're arguing that it could have launched the mission for significantly less than the $148 million value that ULA contract got. ULA argued that it provided schedule assurance needed for that mission that Muscat launched within that 20-day window to actually get to where it needs to go. SpaceX dropped the protest eventually, but looking at things today, I do think SpaceX would have a problem with that 20-day window, because they're quite efficient now. But on the ULA side, I would have seen red if this was on a Delta IV heavy rocket, but very luckily it was on that Atlas V. It's been absolutely outstanding since day one, really.
Yeah, it has been. But as we've seen with Enroll 44, Delta IV Heavy shouldn't be used for these kinds of missions.
Yeah, I've said it before, and I'll say it again. Delta rocket's getting retired next year. I'm assuming there's probably underlying problems with that rocket. That's why the Atlas V's taken over, because the Atlas V's been modified with the Vulcan Centaur rocket technology. Within reason, although the Atlas is older, it actually has newer technology than the Delta rocket.
Yeah, that's true. And it's a good way to test everything out before actually going to launch with the Vulcan rocket. Yeah,
in terms of the Lucy mission itself, Mikko, can you tell everyone what the mission will actually be doing itself? Is it like surveillance mission, or like actually collecting any kind of samples?
No, this doesn't have any sample returns, so it's just going to fly by every of those 8 asteroids and do science.
Yeah. I assumed that, but I was just at the back of my mind because we've seen a few sample collection ones that are like, are they collecting a sample?
Yeah, I think the next sample collecting mission would be from Mars, because they are supposed to return the samples that the Mars Perseverance rover will collect.
Jumping from the most metal rocket, the Delta IV Heavy, that sets itself on fire, to jump into a very metal planet, or asteroid, if you like, or body of sorts. There's the Psyche mission, isn't there?
Yeah, the Psyche mission is going to the asteroid that's named 16 Psyche, and what's unique about it, it appears to be an exposed nickel iron core of an early planet, one of the building blocks of our solar system. So it's interesting to think, could there have been another Earth or another gas giant, and this may be its core?
It does make you think, like, if that was the core of a planet relatively nearby where we are within reason, it's just like, what the on earth happened to its surface if it did have one? Because if you imagine our center core solidified as like a solid metal or of some sort, or turned into just a solid body, imagine like what happened to the surface. Did it get obliterated by an incredibly large asteroid? Did the moon eventually deorbit and hit Earth and obliterated it, or what? It's just incredible to think what might have happened.
Yeah, indeed. I really have no idea what would have happened to it. Have you heard that Mercury could be gas giant's core? There has been some papers about that, and it could have been another Jupiter-like planet.
Yeah, there's loads of theories out there, isn't there? Some more solid than others, but it's another one of those things. We just won't know until we send more missions there, really. A bit like Venus and many others. There's been so much focus on Mars, Moon, everything else. Some things have been overlooked, really.
Yeah. So the important thing about the Psyche mission is that we really can't reach Earth's core, so we will get real good data from Psyche.
Yeah, definitely. There's just more information.
Yeah, and it's really something different to other asteroids. Instead of the usual rock and ice asteroids, comets, this is the metal world, so it's really interesting to see how it looks. I think the orbiter should have some heavy metal tools for the journey.
Yeah, so that the Psyche mission will actually launch August 2022 on a Falcon Heavy rocket. I wonder what that configuration will be. We're quite interesting. Any guesses to that? The launch contract was 170 million, so I guess all boosters recovered from that one, maybe.
Yeah, that sounds plausible, because price of the Falcon Heavy with all recoverable configuration is about 95 million, so SpaceX can't really put the price much lower than that.
Yeah, and for a heavy lift rocket, that's an absolute steal, really, when you think about it. So that's the Atlas V will cost in the region of 110 million for the OSIRIS-REx mission that's just recently been gone. So to consider that the Falcon Heavy will only cost 117 million is quite staggering, really, because that's actually going to be made up of 3 large center cores. It's quite impressive, the cost.
Yeah, indeed. The Psyche orbiter will take about 3.5 years to reach the shiny asteroid, and it's gonna arrive in January 2026, and it will complete a Mars gravity assist in 2023. And the orbiter is expected to do science just under 2 years, but with NASA's history with the spacecraft, I wouldn't be surprised to see it alive in 2030s.
Yeah. It's quite disorientating, because you always see all these missions and then it's like 2 or 3, 5, 6, 7 years in the future.
Biggest winner here is probably the Voyager missions, going about 40 years. But the value of minerals on 16 Psyche is bonkers. It's said to be $700 quintillion. That's enough to give everyone on the planet about $93 billion. And I wouldn't really be surprised to see asteroid mining in Psyche within a couple of decades.
Yeah. Just to backtrack a little bit, I read about this before, so this mission and a few of the others. It's quite intriguing that it's the core of very early planets and stuff like that. Something must have just severely drastic must have happened to it theoretically, if that was true and everything. Just to bounce back on our multi-planetary side of things that we've been looking at recently as well, it's obviously be a key target for once we're at Mars and everywhere else.
Yeah, definitely. First it will be Moon and Mars, and then the next thing is probably gonna be some asteroid.
Yeah, definitely. But it'll be a key mining, like you say, just backtracking a bit there, just that amount of minerals there, $700 quadrillion. It's just like you just can't even fathom that amount of money in real life.
Yeah. I think it's quite a bit more than everything worth on Earth.
Definitely. And that amount of money just from that one source. That's not including minerals that might be found on the moon, minerals that might be found on Mars and elsewhere.
Yeah.
Just puts it into perspective, the amount of potential metals and materials we can harvest from out in space. But then it's kind of like asking the question, we've already ruined the ground we live on, where we are now. It's what we're going to do with the universe.
Yeah, I think asteroid mining should be limited to building in space that the materials wouldn't come back to Earth.
Yeah. I think we've recently got the Hayabusa stuff returning soon, haven't we? In the next, I think it's 75 days or so.
Hayabusa was a robotic spacecraft developed by Japan Aerospace Exploration Agency, or JAXA, to return a sample of material from a small near-Earth asteroid named Itokawa. Hayabusa was launched in May 2003, and rendezvous with Itokawa was in 2005. And after arriving, Hayabusa studied asteroid shape, spin, topography, color, composition, among other things. And in November 2005, it landed on the asteroid and collected samples in form of tiny grains of asteroid material, which were returned to Earth aboard the spacecraft on June 2010. But I think the sample collected was so small that they decided to do a second mission.
Yeah, they've done like a second backup mission. There's two missions, and one of them's due back in the next 70 days or so. So OSIRIS-REx, Hayabusa, there's been many other missions collecting samples from asteroids and everything. So NASA aren't the only ones doing it. There's obviously guys in China, Japan doing all that stuff, and other countries around the world. I believe the ESA launched a few missions as well.
Yeah, they did. I think there was Rosetta that didn't end up too well. And even this year, China is going to send a lander to Moon for a sample return mission.
Yeah. And I believe the Russians are developing some sort of craft to A, land on the moon, and B, collect their own samples on asteroids and everything like that. So I believe they're a little bit behind, but everyone's getting involved with all that stuff now.
Yeah, totally.
Okay, guys, thanks for listening this week on this week's Deep Dive. I'm Ryan.
And I've been Mikko. And don't forget that you can send us questions directly from the Anchor website. The address is anchor.fm/totalspace/message. See you guys in another episode.
See you guys soon. Thank you very much.